Introduction to Linear Regression. Understanding linear regression. What is linear regression? Linear regression is a statistical that allows you to study relationships between two continuous, quantitative variables. It's a way to model the relationship between a dependent variable and one simple linear regression, or more, multiple linear regression, independent variables. Let's break this down. Dependent variable. This is what you're trying to predict or understand. Independent variables. These are the predictors that you think have an effect on the dependent variable. Purpose of linear regression. The main goal is to find a linear relationship between the independent and dependent variables. This relationship can help you understand how changes in the predictors affect the outcome and can be used to make predictions. The mathematics of linear regression. Equation of a line. You might recall the equation of a straight line from basic algebra. Y equals mx plus b. Y, dependent variable. X, independent variable. M, slope of the line. B, y-intercept. In linear regression, you'll use data points to calculate the best values for M and B that minimize the error between actual and predicted values. Visualizing linear relationships. Importance of graphs. Graphs play a crucial role in understanding the data and the relationships between variables. They help you visually verify the linear relationship. Plotting data points. Graphs such as scatter plots are used to visualize the relationship between two numerical variables. Each point represents an observation in your dataset, plotted against the independent and dependent variables. Drawing the line of best fit. The line of best fit, or regression line, is drawn through the center of the data points that minimizes the distance between the line and all points. It represents the best linear relationship between the variables. Implementing linear regression in real life. Practical example: housing prices. Imagine you're tasked with predicting housing prices based on the size of the house, in square feet. Here's how you would approach this using linear regression. 1. Collect data. Gather data on house prices and their sizes. 2. Plot data. Create a scatter plot with house size on the x-axis and price on the y-axis. 3. Perform regression. **** use statistical software to compute the best fit line. 4. Interpret results. Analyze the slope and intercept to understand how house size affects price. Predicting new data. Once the model is created, you can use the regression equation to predict the price of a house based on its size. For example, if the equation is y equals 150x plus 10,000, for a house size of 2,000 square feet, the predicted price would be y equals 150, 2,000, plus 1000 equals 310,000. Closing square bracket. Common challenges and solutions. Outliers. Outliers can skew your regression model and give inaccurate predictions. Solution. Inspect your data visually and statistically to identify and handle outliers. Methods include trimming, removing, transformations, or using robust regression techniques. Nonlinearity. If the relationship isn't linear, linear regression won't provide accurate predictions. Solution. Explore the data further. Perhaps a different type of model, like polynomial regression, would work better. Multicollinearity. For multiple regression. This occurs when independent variables are highly correlated. It can make your model unstable and the interpretations of the coefficients difficult. Solution. Check correlation matrices before model building. Consider removing or combining highly correlated variables. Exercises and discussion questions. 1. Create a scatter plot. Given a dataset of 30 points showing the weekly study hours, independent variable, and the corresponding test scores, dependent hook, create a scatter plot. Where would you estimate the line of best fit would lie? 2. Interpret the equation. If the regression equation for predicting salary based on years of experience is y equals 980x plus 15,000, what do you believe y and x represent? What does the slope tell us about the salary increase per year? 3. Discuss the impact of outliers. How do you think outliers would affect the slope of the line of best fit in your scatter plot from question 1? By engaging with these concepts and exercises, you're building a strong foundational understanding of linear regression. As you progress, you'll learn more complex techniques and see how linear regression can be expanded to multiple variables and used in various fields beyond simple predictions.